In the last section, we were looking at vectors in 2 dimensions, and we did a lot of work there. But now we're going to kick it up a notch, and we're going to look at vectors in 3 dimensions. This is, after all, multivariable calculus, which means we will be spending a lot of our times in 3 dimensions. So, first thing we need to do is kind of back up and go over what the 3-dimensional rectangular coordinate system is and how it works. So, back in school, a long time ago, you saw this object, which is called a number line. And a number line is the real numbers. And it has 2 portions to it, right? When you plot a value, x, right, it's going to be on that number line. So x is going to be a 1-dimensional value. It's in the real number system. So the way to abbreviate the real number system is a capital R with an extra vertical bar in it. Not that we couldn't plot in the complex number system as well, but we're not plotting in the complex number system. That is its own graphing grid. So we're not dealing with that. And when you do this, it's space is split. Your vertical or your linear space is split into 2 parts, right? The negative part and the positive part. Okay, now we did that a long time ago in like elementary school, but then we spent a lot of time in this place, which is the XY axis that we learned in algebra class, then we used it in pre-calculus and Calc 1 and Calc 2 and so on. All right, so when we plot a point, we're plotting an X and a Y. That X and Y is 2-dimensional. And the way to abbreviate that is it's in R squared, because of course there's a grid behind this, right? It's the real numbers for the X, the real numbers for the Y, and they make a grid, right? The squared, R squared. All right, so space is split, and we know this because we've learned this, into 3, 1, 2, 3, I almost drew 4 where I should have drawn 3. 1, 2, 3, 4. So space is split into 4, and they're parts, but we call them quadrants to kind of reinforce the 4 piece with the Latin. Quad meaning 4. Okay, so now we're going to take that 2-dimensional piece and we're going to add a 3rd dimension, and that's what makes it 3-dimensional. It's the same XY plane. As a matter of fact, the XY plane is right here. See the green plane right there? That's the XY plane. That's this plane right here. But you're adding a Z dimension to it. You're adding this 3rd dimension, which splits the space into octants. There's this piece right here in the front. There's that piece right there in the back. And then so on and so on. So there's 1, 2, 3, 4, 5, 6, 7, 8. Or actually, in this case, this is octant 1 over here, because this is where, oh no, it's right here. It's where X, Y, and Z are positive. It's coming out at you on the screen. But you can see that you're already having kind of, if you stare at it too long, your eyes start playing visual tricks with you because you're drawing a 3-dimensional representation, but on a 2-dimensional space. That's why, 3D movies are so interesting, because 3-dimensional implies this depth that you can kind of see, and you get that with perspective. So you have an X and a Y and a Z, but that's in 3-dimensional space. Sorry, let me say that 3-dimensional. So it's in R cubed, right? The real numbers. So the XY plane right there is the XY plane that you know and love, and you add another dimension to it. So that makes it R cubed. So there's little cubes in here rather than squares, right? You could fill it up with sugar cubes or Lego blocks. That'd be my favorite. Okay, so it splits the space into octants, and you can really see it. It's harder to see over here, even though this is what we draw on more of the time, but they're here. So there's one here in the front. There's another here in the back. There's another over here, kind of back behind there. There's another one right here. So there's 4 here, and then there's 4 more down below. Right? So that's 8 octets. So space is split into 8. And to reinforce the fact that there's 8 of them, we again use the Latin oct, right, meaning 8. So octets. I say Latin, but it could come from the Greeks. I wouldn't be surprised. The Romans stole a lot from the Greeks. Okay, so this picture over here is depicting those octets. Oop. Hold on one second. I had the wrong page. All right, so you can kind of see the different octets and see how they work. So octet number 1 is the one we work in the most often. That has X, Y, and Z positive. And you'll notice this has the Z on the vertical axis. That's the most common way for us to work. So it's not that the other ways of drawing the octants or the three-dimensional axes are not valid, because they are, but it's most common for us to draw X coming out at us, Y over here, and Z here. So this XY plane is right here. That's the XY plane that you know from Algebra 1 and Algebra 2. Right, the x-axis and the y-axis, and we're adding in this vertical dimension. So octet 1 has X positive, Y positive, and Z are positive. Right? Octet 2 has X negative, but Y is positive, and Z is positive. So all 4 of these have Z positive. So the first 4 are Z positive, the bottom 4 are Z negative. So for example, this one over here has X positive, but Y is negative and Z is negative. This octet right here is X, Y, and Z are all negative, and so on. So you can kind of figure them out. But basically it starts in the top right corner and kind of works its way around the top, and then goes down to the bottom and works its way around the bottom in a counterclockwise fashion. All right, so now let's draw a point in 3 dimensions and see what happens. All right, this is the exciting stuff. So, well, it's not that exciting yet. But if you want to get to a point P, you have to go out EA over B. Let me see if I can get some colors here. Up C. C I'll make orange. And then over B, I'll make that green. There you go. So you go out, over, and up, right? So the point would be A, B, C, right? Those 3 values in an ordered triplet would make your point P. Now the problem with this is that if you just draw P where it's drawn right here, same spot, but you have it just sitting there floating, you don't really have any sense of where that is. Is it this direction in octet 1, the way it appears to be from this particular way I did it? Or is it actually back behind and under? Is it in octet 7? Or is it in the back over here? Is it in octet 2? You don't really know, right? So to know where P is, we need perspective. Perspective is that thing you learn about in art class. It's the thing that they got from during the Renaissance time. That's what makes Renaissance art, right? Is that it has perspective, right? Michelangelo had perspective. You could look at his paintings and you could tell how the 3-dimensional objects were supposed to be, even though it was on a 2-dimensional flat surface, like a canvas or a ceiling. And that's because it had perspective. You were able to tell visually what it looked like. So we will do our best to draw perspective as best we can in this course. It won't always be easy, but we're going to do our best. And we will make computer programs do a lot of the heavy lifting for us in terms of 3-dimensional drawing. But let's practice here. Okay, so the way these work, again, you need X Y, and Z. Let me see if I can give these some color here. There's Y, and then Z. Beautiful. And so we can draw them kind of at the end of a box, and we would know where that point is because of that box. It gives us a more realistic view of the three-dimensional space, which is hard to draw on this flat two-dimensional surface, but we're going to do it. Again, we're not artists, so we're just going to do our best. Points are actually pretty easy, relatively speaking. Okay, so let's start with 3, 4, 6. So we want to go out 3. So we want to go 1, 2, 3. So we're going to go out 3. And then we want to move to the right 4 because that's our y's, right? Remember how this goes. X, Y, Z. So now we want to move 4. Now if we were back here, we would move 1, 2, 3, 4, and we'd end up here. But because we're down here as our starting point, it's like vector addition. You have to move 1, 2, 3, 4 here. Right? So in other words, there's kind of a parallel line to that green one over here. And there's a parallel line to that blue one over there. Right? You're forming the bottom of your box. Right? The base of your box is sitting in the X, Y plane. And now you have to lift it up. So you're going to lift it up 6 units. So normally you'd go, right, 1, 2, 3, 4, 5, 6, and that would get you here. But you have to do it from this spot. So 1, 2, 3, 4, 5, 6. I hopefully did my best. And there we have it. So that's going to get us to the point P. And you can see, hopefully, that 1, 2, 3, 4, 5, 6 would have a parallel line like that. And they would have right? You're forming a box out of the dimensions you have to get you to this point P. Okay, so let's do it again. 5, negative 4, 2. Oh, that's going to be tricky because it's got some negatives in it. So 1, 2, 3, 4, 5. So we're going to come out 5 this way. And then we're going to go negative 4 in the y direction. So 1, 2, 4. And what I'm going to do is I'm going to draw the parallel line right now for that green one. So that's going to get me that. All right, so then my horizontal is going negative 4. So it's going to look like that. Right, the solid ones are the ones I'm actually using. Although vectors are free, so technically any of them could work. But all right, so I went out 5 over negative 4, so I went to the left, right? And now I want to drop down 2. So down 2 would be down like this. So down 2 would be down like this. So down 2 would be down, right? And if you think of it, there's your point right there, right? So you've got this piece right here. Sorry, that's not the same blue. This piece right here. You formed a box. And that point, Q, is at the bottom corner of that box. So you're using basically tricks to visually cue for yourself where the point is. Because otherwise, if I took away this perspective building with the box, you really don't know where that is. That could be back behind in quadrant, or excuse me, octant. Well, it's currently in octant 8, but it could have been an octant 7. It could be anywhere, right? So you don't really know until you've drawn the box in.